Today we are going to be talking about 7.1c, which is square and square roots. So when we're trying to find the square root of something, so if I say, what is the square root of 16? We are trying to find two numbers that are exactly the same that give you 16. So I'm going to do all of the problems that you could do to get 16. So we could do 1 times 16. We can do 4 times 4. 8 times 2, and I think that's it. So when we look at these problems, okay, I would look and I would see that my 1 and my 16 are not the same. Okay, these are not the same number, so that's not going to be my answer. My 8 and 2 are not the same, not going to be my answer, but my 4 and 4 are. My answer is not going to be 4 times 4, but the square root of 16 is going to be 4. Okay? So 16, square root of 16 is what you call a perfect square. And that's what we're going to be dealing with all this year, are any numbers that are perfect, which means they have two whole numbers that multiply together to give you the square root. So for example, if I have square root of 25, I'm thinking of a number that I multiply by itself to give me 25. Okay, so I know 1 times 25, and I know 5 times 5. So of course my answer is going to be 5. Now we talked about in class about square roots and different types of squares. Okay, if I want to represent a square, first of all, what do we know about squares? We know squares have 4 congruent sides. Okay, that means they're all equal. So that means if this is 3, this is going to be 3. Okay, if we change it and this is 4, then this is going to be 4. That's just something we know about squares that's easily identified by the characteristics of what a square is. That's how you know a square is a square and not a rectangle, right? So here, if I go ahead and represent this square here, okay, I have 1, 2, 3, 4, 5, 6, 7, 8. I have 9 squares total. Okay, so this key number right here means this square represents the square root of 9. Okay, or it represents 3 squared. Okay, because 3 times 3 is 9. Okay, we know this little 2 up here tells us how many times we're going to write our base number. So if that little number says 2, we're going to write our number 3 times, and we're going to multiply 3 times 3. Okay, so another drawing. If I had this, this is 1, 2, 3, 4, 5. Does this properly represent 5 squared? No, it doesn't. Because we know that 5 squared is 5 times 5, which is 25. And are there 25 squares there? No, there's not 25 squares, but there are only 10. Okay, because this is a 5 by 2. 5 times 2 is 10. Okay, so no, this is not a perfect square. Okay, so now if I ask you the square root of 64, okay, what is a number you can think of multiplied by itself that gives you 64? Correct answer should be 8, okay, because 8 times 8 is 64. Okay, same with 144. What two numbers can you multiply together to give you 144 that are identical? 12. Good, because 12 times 12 is 144. Okay, now if I asked you if I just wanted a side length, okay, I'm going to tell you that there are 100 squares in here. And there's really not, because I'm not going to be able to draw that many. Let's see how many there are. 1, 2, 3, 4, 5, 6, 7. Let's see if I can do 7. Alright, so here in this square, there are 49 squares. How do I know that? Because this side length is 7 and this side length is 7, and 7 times 7 is 49. Okay, so this represents the square root of 49. If you're ever asked, I just want one side length, right? What could represent one side length of 7? The square root of 49 is going to be correct. It's not going to be 7 squared because that equals the whole area of 49. And we know we're not looking for the whole area. We're just looking for this one side over here, which is 7. Okay? So make sure you pay attention to the questioning. I'll try to get some examples of real life problems up here for this slide if I see that we're struggling with it some more. But I hope you understood this lesson, and if you have any questions, make sure to ask me in class. Thanks so much.
Made with Doodlecast Pro.